Hey, once again, everybody, this is Professor Sebastian back to our statistics class notes, and we're on the last page of our Chapter 4 notes. We're on page 59. So this is a Chapter 4 quick review just to make sure the main points of Chapter 4 are quickly got across one more time. The scatter plot below shows what type of relationship between the number of runs scored and the number of hits for a group of baseball players. So first of all, you see a scatter plot. We got number of runs scored on the x-axis. So number of runs scored is trying to be used to predict the number of hits that any team might have. And we can see we got a pretty strong positive, right, uphill linear relationship, right? It looks like it follows a line okay, and there's no curve into this. So how do we interpret this? As the number of runs scored by a group of baseball players increases, right? As X increases, the number of hits they have also tends to increase. Y also tends to increase because it's a positive relationship. Let's say there is a negative association between the percentage of smoke-free homes and the percentage of high school students who smoke. So this means what exactly? Negative association. So as X increases, Y tends to decrease. So as the percentage of smoke-free homes increases, the percentage of high school students who smoke tends to decrease. Number 3, for a certain group of cars, there is a strong association between the city and highway mileage that can be described by the following regression equation. So we have the predicted highway miles per gallon is 8.25 plus 0.87 times the city miles per gallon. So we have Y equals B plus MX. So we want to interpret the slope. So the slope is M, which is 0.87. So what does that mean? That means if X increases by 1 unit, then Y increases by the amount of the slope. So in other words, if the city miles per gallon is increased by 1 mile per gallon, the predicted highway mile per gallon is increased by 0.87 miles per gallon. Which of the following correlation coefficient values indicate the strongest association between two variables? Often we ignore the negative sign thinking, oh, that's a bad thing. But remember, anything close to -1 or +1 is a strong association. If it's close to -1, it's a strong negative association. If it's close to +1, it's a strong positive association. So this is the closest value to -1 or 1. 0.78 is the closest positive value to 1, but negative 0.98 is closer to -1 since it is the closest, okay? And when doing a regression analysis on a data set, which of the following remain the same no matter which variable is chosen for X and which is chosen for Y? Well, the y-intercept of the regression equation definitely changes because the regression line equation changes if you switch X and Y. Remember, I talked about it quickly being the inverse function, right? But don't worry about that. We don't need to know how to do that. We just let StatCrunch find the equation. But if you change X and Y, then certainly it's going to change the y-intercept. It's also going to change the slope because that's part of the regression line. But recall, the most important thing here is that it does not change the correlation coefficient. Okay, that one remains the same.